the system here. So this is -2, -6, 0, then 1, 1, -2. The right hand side is 1, 2, -1. Okay. This is a system with 3 equations and 2 variables. The variables are C1 and C2. Let's reduce this in the calculator. Okay, here it is. Now, so the conclusion is that the last row doesn't mean anything. All zeros, right? Doesn't mean anything. And then the second row says the C2 is 1/2. The first row says the C1 is -1/4. Alright, so we found the C1, C2, so we were able to find the linear combination, right? We were able to write this vector as a linear combination of those two. So this vector here is in the span of these two, right? So 1, 2, -1 is in the span of S2. Okay, and then we need to do what? Check if this vector here is in the span of S2 again. So we need to do the same procedure. Now you put this vector here on the right hand side and then see if you can find the C's. Well, this should be a very quick procedure, okay? So all I have to do is to change this matrix here, change the right hand side. So let me put the calculator here so you can see. There it is. Let's go to the matrix. Put the matrix here. Okay, so just change the right hand side. Okay, now I put 0, 1, 1. And then reduce. See, I found the C's again. Okay, so let me write that here. So it's negative. If you want to see fractions, there is a quick way to do that. That's very nice. Just press math and then fraction. The calculator converts that into fractions. That's so nice. So you can see that for, let's write this here, for 0, 1, 1, we have C1 equals to -1/4, and C2 equals to -1/2. So the 0, 1, 1 is in the span of S2, okay? Right, so that's the idea. Same idea here. I'm just making it, abbreviating it a little bit. And then finally, the third vector, the 2, 5, and -1. 2, 5, and -1. Let's see if we can find the C1 and C2, okay? Here's a calculator again. Go to matrix, change the right hand side of the system. 2, 5, and -1. Okay, let's reduce that. Okay, so negative 3/4, right? And -1 and +1/2. Oops, I don't know what happened here. Negative 3/4 and 1/2. Is that negative? Yeah, negative. So 2, 5, -1 is in the span Okay, so all three vectors are in the span of S2. Therefore, the span of these three vectors here is contained in the span of S2. Okay, so that's the conclusion here. The span of those three vectors in S1, is contained in the span of S2. Okay? Now we need to show the other way. We need to show the span of S2 is contained in the span of S1. So the idea is the same. So let's now write okay, what are the vectors in S2? Okay, here it is. Part B, we need to show that the vectors in S2, okay, these are vectors in S1. Now the vectors in S2 are these two here. So -2, -6, 0, and 1, 1, -2 are in the span of S1. Okay? How do we do that? Well, let's pick each vector here and see if they can be written as a linear combination of vectors in S1. So what is S1 again? S1 are those three vectors here, right? Here, those three vectors. S1 has the three vectors there, and S2 has those two vectors. Okay, so we make a linear combination of vectors in S1. That's C1, 1, 2, -1, plus C2, the second vector there is 0, 1, 1, plus C3, 2, 5, -1, and see if you can write this vector here as a linear combination of these three. Okay, let's do that. Okay, so here's the matrix. That's the system that we get from here. Let's put that in the calculator and reduce and see if we can find C1, C2, C3. Okay. All right, this is the reduced matrix. The last row, it doesn't mean much. But since we have three variables, we have C1, C2, C3, this really means that C3 can be anything. Can be, that was too close, right? Can be any number, any real number. And then that C2 is -2 minus C3, and that C1 is -2 minus 2C3. Okay? So that means what? It means that we can, right? We can find C1, C2, C3. Just give a number to C3. So let's say C3 equals to 0, right? C3 equals to 0, and then C2 will be -2, C1 will be -2. So in other words, we were able to write this vector here as a linear combination of these three. So the vector -2, -6, 0 is in the span of those three vectors here, right? That's S1. Then now let's do the same thing with the second vector here. For 1, 1, -2. Let's do that. If I do that in the calculator, let's do that here. Let's put the calculator here. And then all we have to do is to change the right-hand side, okay? So let me go back to the matrix, which is a 3×4 matrix. I already put it there. And then the right-hand side will be, instead of -2, -6, and 0, let's do 1, 1, -2. 1, 1, -2. Okay? and reduce that. Okay, so what is the conclusion here? The conclusion is that the last row, all zeros, that means C3 can be any real number again, right? So I won't write that in here, but you can see that C3 can be anything, and then C2 will be negative 1 minus C3, and then C1 will be 1 minus negative 2C3. 1 minus 2C3, right? So in other words, you can find C3, just give a number, and then you should be able to find C2, you should be able to find C1. So therefore, we were able to write this vector here as a linear combination of these three. So we are able to find C1, C2, and C3. So that means the vector 1, 1, negative 2 is in the span of S1. Okay, so both vectors are in the span, so that means the span of these two vectors is contained in the span of the S1. Span of S2 is contained in the span of S1. So the main conclusion from A and B, span of S1 is equal to the span of S2.